Hello everyone, myself Subhashini from Wiltech Madritech, Dr. Rangarajan, Dr. Shakuntala Engineering College from the Department of Artificial Intelligence and Data Science. Let us discuss the topic of computer vision and what are the key tasks available. First, let's take a look on what is computer vision. Computer vision is It is a field of AI that enables computers to interpret and process visual data from the world like images and videos. A technology that machines uses to automatically recognize images and describe them accurately and effectively. And these are the key tasks in computer vision. First one is image classification, object detection, recognition, and rendering and reconstruction. Image classification. Image classification is a branch of computer vision that deals with categorizing images using a set of predefined tags on which an algorithm has been trained. That is, image is classified into this particular category. That is what based it is categorized, and it is classified into what are the algorithms that the images is trained. Based on that, it is classified. That is image classification. And next one is object detection. Based on the classification, according to that image that is captured, what are the object that is detected in that frame that is recognized by using the object detection. And next one is recognition, that is like in that video or in that photo image, we can able to find that what is the face or something, any animals, some what are the faces available, what are the instance we can find, that is used in recognition. Next one is rendering and reconstruction. Reconstruction creates a 3D digital model of the real world object or seen from 2D images, or rather sensor data, while rendering uses this 3D model to generate a realistic 2D image from new viewpoints or to visualize the scene properties. These are the tasks in computer vision. And next one is video based rendering. Let us discuss this in detail. Creating new viewpoints or scenes using video input, it synthesizes realistic views beyond captured frames. See, viewpoints is a one that refer to the different perspectives from which the scene can be viewed. That is a viewpoints. That is one point of view. So each one have a different point of view. So what base the viewpoints is captured and it's synthesized into realistic views beyond the capture frames. So next one, which is a common example of video rendering, is a video editor, like combining multiple clips, adding transitions like dissolve and effects, then processing these into a single playable video file. Okay, like in movies or short films, these are the best example for the video based rendering. We'll combine the multiple clips and we can add some effects into it and process into a single playable video file. And other examples, like if we use a mobile camera to take the panoramic video, that is a 3D environment. Creating 3D environments from multiple synchronized cameras and animating still photos with repetitive video textures. So these are some examples of video based rendering. And these are some applications of video-based rendering. First one is virtual reality, sports broadcasting. movies and visual effects, augmented reality. See, virtual reality is nothing but it is used for inside out tracking of head and hand movements. Like if we take one photos or some image, while taking the photo, if the head or hand is shaked, that is taken as a live photo. That is a virtual reality. Okay, this is the application. So many mobiles, the features is available, right? Virtual reality. And that is next one is sports broadcasting, like live cricket watching, live match watching, like football and table tennis, etc. And next one is movies and visual effects. In movies, that is also a video based rendering, like they'll collect multiple clips and then it adds into like animated movies, like Disney pictures and all. It's the best example for video based rendering. They'll create one image and based on that they can also create some videos. See, the tree, the girl with the long hair and the hero coming in the horse. See, same visuals but they'll make as the video. So that is the best animated video, right? Next one is an augmented reality. Augmented reality is nothing but it is a manner in which the compounds of the digital world blend into person's perception of the real world. So the integration of immersive sensations. See, if we take one picture where it is standing a red color car, we can change that what we will think. That is digital one with the person's perspective. We'll blend that perspective into the digital photo. That is an augmented reality. Okay. And these are the techniques available in rendering. First one is image based rendering, video based rendering and neural rendering. Image based rendering, in this method they take and input a series of image of the scene rather than the model containing geometry and material specifications. These methods combine the provided images and use them to form a new image from different camera locations. Okay, this is the image based rendering. Next one is video based rendering. Video based rendering is nothing but it uses video sequences as input to generate novel video outputs, allowing users to create new views like animations or engaged versions of existing footage. Okay, like example, we take dynamic scenes like phenomena like fire or waterfalls. This is the best example for video based rendering or VR. Neural rendering, this is an emerging field in computer graphics and machine learning that combines deep learning models with traditional rendering techniques to generate realistic images and videos like light fields, etc. Next one is challenges in video rendering. These are the main challenges that are facing in video rendering: occlusion handling, motion blur, complex lighting, high conceptual cost. Example methods: light fields, neural radiance fields, view synthesis networks. Light fields are one which uses specialized cameras to capture not only the spatial, that is where it is located, that is the position where, but also the angular, that is which direction information of light rays, enabling engaged 3D understanding of scenes. Okay. This is the main aim of light field, like where and which direction it is engaged. Okay. Neural radiance fields are the deep learning technique that uses neural networks to represent a 3D scene from the collection of 2D images, enabling the generation of photorealistic novel views from a new perspective. So collect the 3D images, collection of 2D images and transform that into a 3D image. That is a neural radiance field. In view synthesis networks, generate a new images of a scene from viewpoints that is not present in the input, utilizing various deep learning approaches like neural radiance fields and other techniques. Okay, that is, it is not present in that input, it takes the viewpoints and it utilizes that particular image. Next one is, these are the features of future, what are the rendering techniques available, like realistic avatars, metaverse applications, real-time immersive VR, virtual reality. Okay, let us discuss this in detail. Realistic avatars, like we are the avatars, like our photo is an avatar. So that our photo, like a profile photo, that is in a realistic manner. So not like one imaged one, which is in a realistic one. Okay, in future we can see that rendering techniques like our photo can be realistic one. And next one is a multiverse applications. Multiverse means, if like we can see the educational and education in a remote access, like virtual manner, and also in a healthcare products and healthcare in a virtual training and remote consultations, and everything is based on the virtual reality. If we want to go to one showroom for car buying and all, if we don't need to buy, we don't need to come for a live location. So if we want to buy one particular brand of the car, we can take that particular website and we can load that file, which you can visualize that car and you can sit on that car, you can drive on that virtual manner, how it is processing, like that we can able to see. That is a multiverse applications, metaverse applications. And another one is real-time immersive virtual reality. In this, a digital experience that provides a convincing, interactive, and immediate sense of presence in a simulated environment, which users can perceive and react to changes and events as they happen. So, for example, if we want to take what are the things available in that particular feature of that car, it reacts like immediate one, that is the interactive one. So these are the feature rendering techniques we can see. Next one is object detection. Object detection is nothing but it is detecting an object in the images, like with bounding boxes and class labels. That is example, detecting cars, people, animals in photos. These are the traditional methods available to find an object, that is histogram of oriented grains, HOG. Next one is SVM classifiers, and next one is sliding window search. HOG is a feature descriptor used in computer vision for object detection by counting the occurrence of gradient orientations. For example, if we have an images, you can spot an object like a ball in that image. So that ball is marked and it is added to that object detection. Okay, and in HOG, based on the gradient orientation, the properties are subcategorized. These are the things that mark the ball, and in darker portions, that is based on the gradient properties, it is segregated. Okay, it works on the, that is the gradient properties are marked as a small portions, that is a small cells like pixels, it is segregated. Okay. In SVM classifiers, they distinguish between two classes by finding the optimal hyperplane that maximize the margin between the closest data points of the opposite classes. Next one is sliding window search. Sliding window algorithm, it is an efficient technique used to solve problems involving arrays, lists, or strings, particularly when analyzing contiguous subsegments or windows of data. It optimizes the solution that would otherwise require nested loops, reducing the time complexity. That is, it segregates the subsegments, that is, contiguous subsegments of the particular order data. Okay. By using this, we can segment the category. These are the traditional methods in object detection. Next one is deep learning methods. It is a next one is region-based convolution neural networks. It is a landmark of deep learning model in computer vision. So it detects and localizes the objects in images. Okay, it works by first generating a region proposals like object locations, then extracting features from these regions using a pre-trained convolution neural network, finally classifying the object within each region and refining its bounding box. Okay, this is a brief about RCC and family. Next one is YOLO, YOLO, you only look once. That is, it is popular and influential real-time object detection algorithm in computer vision. It revolutionized object detection by treating the task as the single regression problem, enabling faster processing compared to older. Next one is single shot detector. This is an object detection algorithm that identifies objects and their bounding boxes in an image by performing detection in a single forward pass of the neural network. Okay. Within the single pass network, it detects the neural networks. So name itself implies that's a single shot detector. This These are the applications of object detection. First one is self-driving cars, next one is security cameras, next one is robotics, and next one is medical imaging. Challenges in object detection is small objects, occultation, real-time requirements, diverse environments. And next one is face recognition. Face recognition is nothing but in an image it recognizes the face until it is whom. Okay, identifying or verifying individuals based on their facial features. Likewise, real-time application in mobile, we can able to label our name, right? If we having a face and they can detect our name using the facial features. Face recognition pipeline. These are the steps that follow to recognize the face. First one is face detection, and another is alignment, and another is feature extraction, matching with the database. First it takes one face and it aligns to some order and some gradient properties, and it next to the feature extraction. These are the features like sharp nose, eyes, retina and all, and it matches with the database properties, and it tells the name, who are this face in the image that is recognized by this. Next one is deep learning approaches. In deep phase, it is a learning based facial recognition system developed by the Facebook, known for achieving near human level accuracy in face verification. So which is developed by Facebook. Okay, next one is a FaceNet. This is a deep convolution neural network architecture developed by Google for face recognition. Each deep learning approaches are developed. First one is developed by Facebook and next one is developed by Google for recognizing the facial features. Its key innovation lies in directly learning and mapping from face images to a compact education space, which distance directly compound from the measure of face similarity. Next one is ArcFace. This is a deep learning model for face recognition that focus on improving the discriminative power of face embeddings by incorporating an additive angular margin loss. Next one is applications of face recognition. First is phone unlock. Obviously, we are using in real time. Next one is security systems. Next one is payment systems, and next one is a social media tagging. These are the applications of face recognition. Issues in face recognition. First one is privacy concerns, dataset bias. Next one is spoofing, that is photo masks and all. We can add a duplicate one or it is morphing one. So this is the face recognition issues or disadvantages. And next one is instant recognition. It is recognizing a specific object instance, not just its category. That is like for example, Coca-Cola versus Pepsi can. Okay, both are same like a tin one, So that is a specific object instance. What is that? This is a Coca-Cola can or Pepsi can. Like particular of both is having a similar difference, right? Minor changes. So that is identified by the instant recognition. Examples of instance recognition, that is a product recognition, next one is a landmark recognition, next one is a logo detection. First, if we take a small, that is if we take a small and similar products, first what is the product and identify the product and identify the landmark, what are the changes in the two products and identify the logo. Okay. These are the methods used for instance recognition. First one is feature descriptors. Feature descriptor, it is a representation, typically a numerical or fingerprint or vector that captures essential and distinctive information about a feature in an image or other data, enabling identification and matching across different views and transformations. Okay, next one is deep embeddings for similarity search. Embeddings are representations of values or objects like text, images, and audio that are designed to be consumed by machine learning models and semantic search algorithms. They translate objects like these into the mathematical form according to the factors or traits each one may or may not have and the categories they belong to. And next one is, what are the applications of instant recognition? First one is retail product search, and next one is robotics object handling, next one is augmented reality. So these are the comparison of tasks. First one is video based rendering, it creates a new views, and object detection is locate and classify what are the object and what is the object is available, and face recognition is identify the face or identify who is that, and instance recognition is identify a specific object. If we say you want to specify some object, it recognizes the specific one. These are the tasks that we have discussed, and these are the some brief one. And key challenges in computer vision are the need for large data sets and high computational power, generalization, and ethics and privacy. These are the disadvantages that we are facing problems in computer vision. And how we can conclude that the computer vision could be the computer vision powers real world AI applications. So nowadays CI only rules the world, right? So everything is AI based one. So we can conclude that computer vision rules the world. So in future, where we can see a computer vision or AI, it is more accurate, ethical, and real-time systems. We can see that in future. So more accurate one and ethical and real-time applications. So these are the topics which have available today discussed. Thank you for everyone.